Well, welcome this afternoon. My name is Ronnie Green, and I have the pleasure of serving here at the University of Nebraska-Lincoln as the Vice Chancellor for the Institute of Ag and Natural Resources and as Vice President of the University of Nebraska for Agriculture and Natural Resources. Welcome to our inaugural lecture for this academic year of the Heuermann Lectures. We started the Heuermann Lectures just 3 years ago. This is our 4th season that we're entering upon this year, where the focus of the lectures are on global food security, natural resource security, rural landscape security around the world. And we were able to do that through the generosity of a long-standing couple who have had huge impact for many, many years on Nebraska agriculture, certainly, and the products they have produced have gone far beyond Nebraska, and we're very pleased that they're here with us today. I think Mr. Heuermann, Keith Heuermann, has only missed one lecture, if I remember correctly, in those 4 years, and he has Norma, his wife, with him here today. They're from Phillips, Nebraska, about an hour and a half west of us here in Lincoln. Please join me in thanking Keith and Norma Heuermann. Now today we're in for a real treat in our kickoff of the lecture series, in that it also is in parallel with the release of a report that we have been working on in the Institute of Ag and Natural Resources for the best part of the last year. And you will perhaps have seen some of the publicity around this. It was in the papers here locally the last few days, where we are talking today about understanding climate change, understanding the impacts that may come from climate change on Nebraska, and on how that might factor into our thinking here in this state and on the resource base that we're blessed to have in this state due to these changes that are projected out in the future ahead of us. Now, our format today for the lecture, we're here on Nebraska Innovation Campus in the Conference Center facility that's new, as you can see, those of you that are here. This is its first year of operation, and we expected that this would be a great venue for this lecture. We'll actually be having a couple of our lectures here this year in this venue. So we're joined by about 400 people here in the auditorium live. Then I know there are a number of people tapped into the lecture in various groups around the state of Nebraska. I know there's a UNO group, a Chadron State group, a Creighton group, all who are either tapped in now or will be tonight to view what our lecturers will tell us here in the next hour and a half. Our venue will be, or our platform in our venue will be 45 minutes initially of a summary of the report. That will be delivered by Dr. Don Wilhite, who has led the study with, I think, about 18 of our faculty across the university, not all in the Institute of Ag and Natural Resources. As you'll see, our 3 panelists today also are from the Department of Earth and Atmospheric Sciences in the College of Arts and Sciences here on campus. Following Dr. Wilhite's presentation, we will have a panel discussion where Don will be joined by Clint Rowe, Bob Oglesby, and Deb Bathke, co-authors of the report, to allow you a chance to dialogue with them in questions that you may have about what the report says. You will see on the desks in front of you, there are note cards that have been distributed throughout the auditorium. So if you have a question that you would like to address to the panel, we ask you to put that on the card, send them toward the end of your row, if you will, and they'll be collected during the lecture so we can begin with that panel dialogue in the second 45 minutes. Everybody on board? So I will now welcome Dr. Don Wilhite to the podium. Don has been an international leader for many years as an applied climate scientist. He's a member of the faculty of our School of Natural Resources in INR, and he's looked at globally as a leader, particularly in the area of prediction of drought and the impacts and implications of drought and mitigation of drought. You will recognize that we house here the National Drought Mitigation Center at the University of Nebraska-Lincoln. We're very proud of that center and the work that it does for us nationally and internationally. And Dr. Wilhite, I follow his travel schedule closely, and he's all over the world all the time, working with groups all the way up the chain in helping us to understand the environment and climate and impacts on drought. So please join me in welcoming Dr. Don Wilhite for the initial part of the lecture.
So they tell me well, it's obviously live. So welcome. I'm really pleased that you could all come to this lecture this afternoon. First of all, I must say this is the first time I've spoken in this auditorium, and it feels somewhat like a Colosseum in ancient Rome. So my first question to Ronnie Green is, at what point are you going to release the lions? So, no, I'm pleased to have you all here. I also would like to introduce, Ronnie mentioned them, but they're sitting in the front row over here, and they'll join us in the panel. I tell you, the four of us have worked hard on this report for about the last 6 to 8 months, and I couldn't ask for a greater group of collaborators than what I've had to work with in these three individuals. So Bob Oglesby is seated closest to me. Hold up your hand, Bob. Clint Rowe and Deborah Bathke. So all three of them have appointments, as Ronnie said, in the Department of Earth and Atmospheric Sciences. Bob Oglesby also has a joint appointment in the School of Natural Resources. So one of the cardinal rules about public speaking is to know your audience. And so as I started thinking about this audience and the diversity of people in this audience and their knowledge of the issue of climate change, because it's a very complex one, I was trying to think of an analogy to the diversity that I see in front of you. You'll know that before I show you my next slide, this report will be available at the end of the lecture, and it'll be on tables around. So this is the analogy, a Nebraska football game. And if you think about the diversity of people that are in the stadium, in terms of their understanding of football, their real understanding of football, maybe you get an idea about the diversity of expertise and understanding of this issue that exists in this particular auditorium today and that are linked in via video links. So I was thinking about this, and it sort of puts me in the perspective of thinking like sort of the Geico gecko, in the sense that, does everybody already know this information? Well, obviously everyone doesn't. A lot of people are on what I would call the novice but eager to learn side. Other people, there are many experts in this room that know as much about this issue or more than I do. So I would ask you, as we go through this, kind of where do you place yourself on this scale between being an expert and being a novice? But hopefully, regardless of where you are in that scale, that you have come to the lecture to learn about this and to learn about the potential implications of climate change projections on the state of Nebraska. So if you came to the lecture hoping, if you're a skeptic, hoping to hear that global warming is a myth, you're going to be disappointed, because I'm not going to say that. But again, I hope you came with an open mind and willingness to listen and to learn about the science behind climate change, as well as the implications associated with that for Nebraska. So this slide says, did you know that 97% of climate scientists believe that humans are causing the current change in temperature, the global warming that we're talking about here today? There's a significant misperception about that amongst certainly the American community. I saw a poll the other day that said only 12% of Americans understand that 97% of the climate science community conclude that global warming is a result of human activities. So we have a lot of educating to do on this particular subject. So the outline for my presentation is going to follow something similar to what we see with the report that you'll have access to following this lecture, both in the hallway in hard copy, but also online. This will be available in electronic format. So we'll talk about the science of climate change. We'll get into issues of the observed changes that we've seen to date, talk about the projections, and also separating natural causes for climate change, which is one thing that a lot of people get confused about, versus human causes. And then we'll conclude with some takeaway points, some challenges and opportunities as we move forward. So, first of all, let's start with the introduction and background. I'm going to give you a couple of definitions, which you might think is a pretty simple place or a beginning point with our conversation, but I think it's important. So the first definition is one of weather. Weather is the condition of the atmosphere at a particular place and time. So it's defined by whether it's cloudy, whether it's sunny, wind speed, temperature, precipitation, all of those variables that we're used to hearing about on our nightly news. As opposed to climate, where we're looking at the composite or the average of weather over a longer period of time, typical averaging periods being 30 years or longer. And so an important part of climate are what are the trends associated with climate. And so this is something we'll talk about. Mark Twain said it this way: climate is what you expect and weather is what you get. So that's another way to make a distinction between weather and climate. Now I bring this up because of the fact that many people get these two terms mixed up or confused by what's weather and what's climate. So let me give you a couple of examples of this type of confusion. So here's a map that shows July temperature, land and ocean temperature of 2014. And if you look at that circle that I've put up on the screen, Nebraska and the eastern United States was cool. We had a cool July and a wet July. So some people will say, well, see, global warming must be a hoax because we had a cool July. And we probably had somewhat of a cool August as well. Roberto Lenton and I just came back from Stockholm recently for Stockholm Water Week, and the people there were talking about what a beautiful warm summer they'd had throughout Europe this year. We're talking about weather, short-term weather patterns that affect the temperature and precipitation and other characteristics of the atmosphere at a particular point in time. So people will say, but if we're talking about global warming, why did we have a cool July? Again, it's weather versus climate. Another example is if you look at a plot of global mean temperature, some people will point to particular years where, like in 2000 and 2008, where global mean temperature actually dropped. Again, that's weather over a short time scale. What's important here is the trend. So again, the confusion between weather and climate causes a lot of people to maybe not understand this issue in so many ways. So we were fortunate. We did an extensive review of literature, building upon the expertise of the 4 members of the team. We also worked with, as Ronnie said, some other people that wrote commentaries on various sectors, so we engaged other people other than just the 4 of us. But 2 very important reports that just happened to come out, simultaneously with our study. First one is the most recent report of the Intergovernmental Panel on Climate Change that does a global assessment of the state of the science for climate change, implications of that, impacts, mitigation options, and so forth. And this report it's actually a number of reports. The first ones were issued in late 2013, the others in early 2014. And so we relied heavily, obviously, on the latest information coming from this group of more than 1,000 scientists that participate in this IPCC process. The second report is the National Climate Assessment Report that was released in May of this year. So this report focuses on the United States, and it's the third report that's been done, and it's generally done about every 6 or 7 years as well. And so this one gives us more information that's more specific to the United States. And so this is very helpful. This report is divided into about 32 different chapters. There are some overview chapters of projections. There are also chapters on various regions, including one for the Great Plains. There are also chapters that focus on different sectors. And so I pulled some of the key sectors for Nebraska, and we used commentaries to essentially discuss those sectors in terms of the implications of climate change on those sectors. And that's in the report, and you'll see that later. So if you look at the IPCC report, and you can read the language at the top there, but if you look at the language in the second paragraph, the evidence for human influence has grown since AR4, which is the assessment report 4 that was issued in 2007. If you remember, this report is the one that won the Nobel Peace Prize because of bringing this attention to this report and this issue to the attention of many people. It says human influence extremely likely at greater than 95%. So from a science perspective, 95% is a pretty high probability. So we believe, the science believes, that humans are the primary cause of the changes in climate that we're seeing today. Okay, secondly, climate change science. So many people talk about the fact, well, we all know that there have been ice ages. We all know that there have been warm periods, and these have occurred over thousands of years. And these natural forces that are causing these changes in the climate are still occurring today, but these occur over long time scales of thousands of years. And so we have issues of changes in a bit in the orbit or the wobbling of the Earth. We have solar output in terms of energy and so forth, and how that varies through time. We have things like El Nino southern oscillation events that again are causing changes in climate. And we have things like stratospheric ozone related to large-scale volcanic eruptions. So these natural influences are occurring today, and they've occurred in the past, and they are the reason, or how we explain, the movement from ice ages to warm periods and so forth. But we also have anthropogenic or human influences on the climate system. It's just that, there haven't been that many of us on Earth for all that long a period of time, and so these influences haven't been that significant in the past. Now we have 7 billion people, projected to be 9 to 9.6 billion people by 2050. So we are having an influence on our climate system. So one of those influences is the increasing concentration of greenhouse gases. CO2 is the one that you hear the most about. But we also have changes in aerosol particles as a result of the burning of biomass, smoke, and so forth, and then also changes in land use. 7 billion people have changed a lot of the land characteristics in the world up to this point in time, and we will continue to do that in the future. So in recent decades, since the Industrial Revolution, we've had a growing influence on the climate system, and particularly since, say, the 1960s, 1970s, this has become more apparent as we look at global temperature changes, regional temperature changes, changes in precipitation, reduction in glacial extent, alpine as well as glaciers in Antarctica and Arctic and so forth. And the land use changes continue as well. So, why is this important? Well, most of you learned, and obviously in your high school science classes, about the composition of the atmosphere. And you know that the atmosphere is primarily made up of nitrogen and oxygen. And then we have this small quantity of CO2 and other trace gases or greenhouse gases, such as methane, nitrous oxide, and water vapor that's also in the atmosphere. And this makes up only 1% or less of the composition of the atmosphere. So people can say, well, why is this 1% so important? Well, it's so important because these greenhouse gases are the heat regulators for the Earth. And so we've known for more than a century that if you increase the concentration of greenhouse gases, you're going to increase the temperature of the Earth. And we can track this back in geologic history as well in terms of how these changes have occurred in the past. So without these greenhouse gases, the Earth's surface temperature would be around 57 degrees cooler than what it is today. So again, these greenhouse gases are the heat regulators. And the concentrations of those in the atmosphere are really, really important. So when we think about the Earth's energy balance, we receive shortwave solar radiation from the sun, our primary source of energy. And when that energy is absorbed by the Earth, it's re-radiated into the atmosphere. And when it's re-radiated into the atmosphere, it's re-radiated as infrared radiation, long-wave radiation. So while the atmosphere is transparent, relatively transparent to the short-wave solar radiation, it is no longer transparent to the longer-wave infrared radiation. And so these are the heat-trapping greenhouse gases that we're talking about. So if energy in is equal to energy out, then we have a steady state in terms of our climate. If we upset that balance, then we change all that. So the greenhouse effect, you hear about the greenhouse effect. And basically I just explained that to you, that again, solar radiation, the atmosphere is relatively transparent to the solar radiation, but it's not transparent to the infrared radiation as it's re-radiated into the atmosphere and eventually back into space. So it then stands to reason that if we increase the level of CO2 in the atmosphere and other greenhouse gases, what we're doing essentially is enhancing the greenhouse effect. And so we would expect the climate to warm. And that, in fact, is what's happening. So if you look at just in recent years, the concentration of carbon dioxide, methane, nitrous oxide in the atmosphere, you can see a rather steep upward trend. You also see the chlorofluorocarbons over here that were increasing rather dramatically until the 1990s, when there was a flattening. And this flattening, if you remember the concern about the ozone hole, and trying to control that in these chlorofluorocarbons were what was causing the deterioration of the ozone hole, or development of the ozone hole. And so you see with international treaties, we've been able to plateau this or bring those concentrations in the atmosphere down. So we can do the same thing with these other greenhouse gases, but it takes agreement globally to do this. Countries have to come together to do this. If we look at a longer term trend or plot of CO2, this goes back 650,000 years. At the beginning of the Industrial Revolution, the concentration of CO2 in the atmosphere was 280 parts per million. By 1950, it had reached 300, and in May of this year, it reached 402. This is going to go to 450, it's going to go to 500 and beyond, unless we do something about it. So people may say, well, you know, we've had ice ages in the past, and we've had these changes in the past. The difference is, as I mentioned earlier, is now we have 7+ billion people headed towards 9+ billion people, all competing for resources, all competing for food. The Water for Food Institute's focused on things like how do we feed 9 billion people in the future, working with other organizations and so forth. This is a huge issue for our future, for your children, their children, and so forth. So the concern is that the changes that have occurred in the past as a result of natural forcings have occurred over tens of thousands of years, whereas the forcings, the human forcings, we're looking at changes occurring in a period of less than 100 years, a rapid change in temperature and effects on precipitation and other things. So, what are the observed changes? Well, we could go into a great deal of detail about these in terms of all the changes we're seeing. I think all of you can understand the fact that we are seeing a lot of changes in our climate. So one way to look at that is, okay, if we had a warming world, what indicators will we be looking at to tell us that we in fact have a warming world? So here you have 10 indicators. The white arrows are those things that we would expect to be increasing. Air temperature over land, air temperature in the troposphere, temperature over oceans, sea surface temperature. And then there are 3 arrows that you see that are black arrows going down. We would expect to see a reduction in sea ice, reduction in glaciers, snow cover, and so on. If you look at the data set for all 10 of these indicators, they all verify that this is what's happening. So there's a lot of data that backs this up, and we have more and more data all the time through satellite images and so forth. So our observation network has increased dramatically. If we look at these temperature changes by decade, we see that, you know, the 1980s was the warmest decade on record. And then look at the 1990s. And then 2001 to 2012, again, even warmer. So increasing temperatures globally, and of course we're also seeing this locally. And what I consider to be a remarkable statistic is if you look at, as through July of 2014, we've had 353 consecutive months where the global temperature exceeded the 20th century average for those months. 353 consecutive months. So we're talking about trends, okay? So if we look at the United States and we say, well, where have we warmed in the United States? Well, the warming in the United States has been largely in the western part of the U.S. and across the northern tier of states. There's been a little bit of cooling in the southeast over this period, and it's looking at comparing recent years to the 1901 to 1960 average. Nebraska is kind of in the middle of all of this, showing some increase in temperature. It varies from one part of the state to another. We see this in a lot of different ways. If we look at the statistics on heating demand, for example, we see that heating demand in the United States is dropping. Why? Warmer temperatures. Well, then what would you think about cooling demand? Well, cooling demand is increasing. So this is a reflection of the changes that we're seeing. Not only daytime temperatures, but nighttime temperatures. Winter temperatures are less severe, and so forth. So this is another good indicator. And this is one of Ronnie's favorite indicators, plant hardiness zones. If we look at the plant hardiness zones in 1990, we can see that the zone between 4 and 5, the line between those two, that I've marked here with an orange line, ran basically through the middle of Nebraska. In 2012, this zone had moved to the border of South Dakota. So these zones are moving northward. And the projections are that these are going to continue to move northward, and I'll talk a little bit more about that in a few minutes. Observed increases in frost-free season. The average for the Great Plains, frost-free season has increased by about 10 days. In Nebraska, it varies from about 5 to 25 days, depending on which part of the state you're in. In terms of precipitation, the greatest increases in precipitation, again, remember that warmer temperatures mean that the air can hold more moisture, so you would expect to increase precipitation. And so along the northern tier of states in the United States, we've had an increase in precipitation. In Nebraska, the results are somewhat mixed. Drying trend somewhat in the western part of the country, or western part of the state, and in the eastern part of the state, some increases. But notice these increases, if you look at the scale over on the right, are relatively minor. We're talking a few percentage increases. If we look at the observed change in very heavy precipitation, one of the things we're seeing is that while the total amount of precipitation that you're receiving on an annual basis may not be increasing for some locations, more of that rain, more of that precipitation is coming in the form of heavy or intense events, which means that more water runs off, less goes into the soil, and so forth. Another big concern is related to extreme events and the frequency of extreme events that we're seeing. And you see here meteorological and hydrological type events, and if you looked at the trend of those going back to 1980, you can see a rather dramatic increase, again with fluctuations or variability from year to year, which is caused by different weather patterns. But what's concerning is the trend, and more recently we've seen even a steeper trend. So why are we concerned about extreme events? Well, they put tremendous social and environmental costs on society, and also tremendous economic costs to rebuild or to recover from these events. So think about Superstorm Sandy, in which more than $50 billion has been allocated to rebuilding from Superstorm Sandy. $62 billion were spent by the federal government in response to the 2011-2012 drought. These are very expensive events, and if we look at the trend, the total cost in billions of dollars is skyrocketing. Who's paying for this? You're paying for this. This is taxpayer dollars. I'll just let you look at this slide. I think it needs no explanation, okay? Okay, so separating natural from human factors. So you've probably all seen a slide that resembles this at some point, looking in books and magazine articles and newspapers and so forth. So here you have the global temperatures, global mean temperatures, and here you have a plot that shows CO2 concentrations in the atmosphere. Obviously a very strong correlation between the two. So how do you separate natural causes, which we talked about earlier, from human causes? Well, we have people that are called climate modelers, and we have general or global circulation models that they run. There are quite a few of those models, and we have a couple guys over here that are very experienced in working with these models as well. And so if we look at this particular diagram, what you see here is that if you run these computer models and we don't include the increasing concentrations of carbon dioxide and other greenhouse gases in the models, what you get is what you see with this pattern here in green, which is actually a slight cooling, is what the models would be projecting. If you insert carbon dioxide and other greenhouse gases back into these models, you get what's shown here in the purple area. And the black line represents global mean temperature. So you can see how closely the global mean temperature trend matches what we see if we include these greenhouse gases in these model runs. So again, it's more evidence that we're getting this right. We understand what's happening in the climate system, and we're able to replicate that through these climate models. So more sort of ammunition or information about this is here you see, again, a plot of global mean temperature and the more recent years with the rather steep upward trend. So remember we talked about that there were natural factors that cause changes in climate, okay? And we talked about what those were. Output of the sun in terms of its energy output, volcanic eruptions and so on. So let's look at those trends. El Nino Southern Oscillation was one. Do you see a trend? If you look at the trend related to volcanoes, there's no trend. If you look at solar energy output, once again, no trend. If you look at other factors, other atmospheric oscillations and so on, once again, you have no trend. If you look at anthropogenic factors, you see a trend that matches what you see up here. This is the chart that comes out of the IPCC report. Okay, projections, future climate, implications for Nebraska. So first of all, a little bit about models, and you may have a lot of questions about models, and I'll point to these guys over here to answer those questions because they're the modelers. But one of the things we've seen since the early models in the 1970s is the models are becoming more and more complex. They're incorporating more information into the models and so on. We get a better understanding of the climate system. We can see these grid cells at which they calculate these changes are getting smaller, and these acronyms here represent the different reports that came out of IPCC. So this is the first annual assessment, our first assessment report, the second assessment report, and so forth, and then the assessment report number 4. You see also more complexity in terms of the number of layers of the atmosphere, number of layers in the ocean that they're able to incorporate in these models. So we're continuing to better understand the climate system, and the technology in terms of computer power is allowing us to run bigger, more sophisticated models and so forth. So when they run the models and they have to look at what are the various scenarios of increasing greenhouse gases that we're going to see in the future. No one knows what those are going to be. We know where we are today, but where are we going to be in 20 years, 40 years, 60 years, and so forth. So the climate modelers look at scenarios. So this first scenario is the red line. It's essentially a business as usual. We just keep doing what we're doing, burning more and more fossil fuel and so forth, adding more and more carbon to the atmosphere. And then you have, at the other extreme, you have a situation where we may be decreasing tremendously the amount of emissions into the atmosphere over a period of time. This is extremely optimistic. Probably won't happen. That's the lower emission scenario. This is a higher emission scenario, and quite frankly, business as usual. We're actually exceeding this level of input of greenhouse gases in the atmosphere. So when people say, well, we can't really believe these models because they're not very good, because look at the wide range of temperatures, and we'll talk about that in a minute, that are in these models. Actually, the largest uncertainty that you see when I give you some temperature ranges in a minute, the largest uncertainty is associated with the fact that we don't know what human behavior is going to be over the next 30, 40, 60, 100 years. We don't know what the emissions are going to be, and therefore where the concentrations are going to go. So how do we go about looking at the implications of all of this on Nebraska? First thing is we assessed the observed changes in climate that we've seen to date. So over the historical record, looking back to the late, say 1895 and that period. Secondly, we tried to interpret the projections that came from the National Climate Assessment Report. These are national in scope, but they also have projections at a regional scale, and we tried to bring those down to Nebraska and interpret what that information was. And then the third step in this process was to invite commentaries from experts in key sectors that we felt were important for Nebraska, and to have these experts talk about what these projected changes might be on each of these different sectors. These sectors were chosen not just because they're important to Nebraska, but all of these sectors, with the exception of the insurance industry, all of these sectors were sectors that were addressed in the National Climate Assessment Report. So we had that as a basis, projections at the regional level of the Great Plains, and then they drew some conclusions with regard to these sectors. So these are included in the report, and I encourage you to read those, because I think there's a lot of great ideas there, a lot of great information. So temperature increases. We don't mean to scare you. We're trying to give you what the science is telling us. For a low emission scenario, we just looked at the graph of that, we're looking at a temperature increase towards the final quarter of this century of 4 to 5 degrees Fahrenheit. And as I said, that's a pretty unrealistic scenario because it means that we're going to have to adopt very strict controls on carbon emissions into the atmosphere. The higher emission scenario is projecting an 8 to 9 degree increase in temperature by the last quarter of this century. That's pretty scary. But again, the uncertainties are really related to the fact that we don't know what the future emissions are going to be. So it's important that we get a handle on those and we understand those relationships. Another key finding is that projected high temperature stress days, so these are days over 100 degrees, are expected to increase dramatically to the final quarter of this century. Under the low emission scenario, 13 to 16 additional days. Under the high emission scenario, 22 to 25 additional days. So try to remember those numbers because I'm going to come back to that in a few minutes. Yesterday we had some conference calls talking to the congressional delegation and to the state senators and so forth, and a question was raised, well, what if we're wrong on, for example, this first set of numbers? We may be wrong, but people need to understand that we could be wrong in both directions. So it's not, people tend to think that we're going to be wrong on the low side, but we could be wrong on the high side as well. The number of warm nights, we've seen an increase in that to date, and this is going to continue in the future. Frost-free season, we've seen quite an increase in the length of the frost-free season, and it's projected at least an additional 2 weeks added onto the frost-free season towards the end of this century. If you look at this in a map form, the low emission scenario, the low emission scenario is 4 to 5 degrees. That's this map here, and you can see how Nebraska sits in that. In the high emission scenario, you can see where we sit at the 4 to 9 degrees. So this map comes out of the National Climate Assessment Report. And this report is mandated by the U.S. Congress, by the way, so it's not something that's being done arbitrarily. Coming back to this issue of the number of high temperature stress days, this is a projection of high temperature stress days towards the end of the century, out to 2099, and the higher emissions scenario are the red bars, the lower emission scenario are the orange bars, and then you see these bars in brown. This is the historical number of high temperature stress days that would occur within these different regions. So if you look at, where are the big losers? Regional losers, the southwestern United States, the Great Plains, and the southeastern United States, with a dramatic increase in the number of high temperature stress days. So, you remember 2 years ago, we had a very severe extreme to exceptional drought in Nebraska and over 2/3 of the United States. One of the characteristics of that drought was not just a deficiency of precipitation, but it was the extremely high temperatures that we were experiencing. So this is the map that shows the number of days over 100 degrees in 2012 between June 1st and September 15th. And I've extracted for a couple of locations, Lincoln and McCook. This is the number of days over 100 degrees in Lincoln and McCook in 2012. Lincoln was 17 days, McCook was 37 days. The average for McCook, based on the last climatological period, is about 11. They had 37. Lincoln's about 5, and they had 17. And you can see the similar comparisons for Scottsbluff, Valentine, and North Platte. So the bottom line here is, if these projections hold out, by the last quarter of this century, an average summer in Nebraska would be comparable to 2012. Think about that a minute. Okay, continuing on, precipitation. There really hasn't been much of an increase in precipitation. In Nebraska, there's been an increase in the northern plains. We saw that on a previous map. A decrease in the southern plains, and we expected that to continue. Again, little change in precipitation in winter and spring in Nebraska. Small projected changes in summer and fall, with a drying trend in the central plains during the summer. An increase in heavy precipitations, we've already seen that that's been occurring, that's expected to continue, and an increase in precipitation. If there's any increase in precipitation, it's largely going to be ineffective because of the increasing temperatures, increasing evaporative demand, and so on. These high temperature stress days, warmer nights, and so forth. So if you look at the projections by season, this is a summertime projection, and you can see this drying pattern up into at least the southern half of Nebraska. Soil moisture, a combination of not much change in terms of precipitation, but looking at the increasing temperatures, the increase in high temperature stress days, the warmer nights and so on, that we would expect maybe a decrease of soil moisture of 5 to 10%. Flood magnitude, because of these high intensity rainfall events, flood magnitudes continuing to increase. And what we've seen in the past is these have been increasing along the eastern margin of the Great Plains because of these higher intensity precipitation events. Snow cover, this is a huge concern because the snow cover in the Central Rockies, for example, is what feeds the river, the Platte River, for example, that flows across Nebraska. If we change the amount of precipitation that they're receiving in the Rockies, more rainfall and less snow, snow melts slowly and it gradually feeds the rivers that flow across the state. Rainfall, on the other hand, runs off very quickly. So if we want sustained stream flow, surface water across the state, the idea of reduced snowpack in the Central Rockies and other places in the Rockies is cause for concern. And if you look at the trend that we've seen so far, we've seen reduction in snowpack. But if you look at the projections out towards the end of the century, we're looking at a continual reduction. Again, increasing temperatures, less precipitation falling in the form of snow. Now, one of the things we've also seen is that the tremendous increase in irrigation in the state of Nebraska has actually had a damping effect in terms of cooler and wetter conditions in our climate. So if irrigation continues as is, we might see that trend continue. But the concern is about the sustainability of our water resources under situations of high temperature stress, more variable rainfall, less snowpack in the west, and so forth, and how this might affect recharge of groundwater and therefore, in the long run, the impacts on irrigation possibilities in the state of Nebraska. So if we look at the map that looks at groundwater level changes in Nebraska between 2012 and 2013 as a result of the drought and the high temperatures that occurred, you can see that there were declines of anywhere of 2 to 15 feet. So what if this were to occur for a second year and a third year and so on? So again, once again, concerns. And so we're looking at additional stress related to climate change because of not only increasing temperatures, increasing high temperature stress days, increasing number of warm nights, increasing evaporation, more extraction of groundwater resources, and reduced recharge. So once again, this is another important consideration. Takeaway points. So let me conclude. First of all, I'm going to give you from the National Climate Assessment Report. They had a chapter that focused on the Great Plains. And so I'm going to give you the conclusions from the Great Plains chapter, with regards to some of the concerns or the key messages for the Great Plains coming from this assessment, again, the National Climate Assessment, which was involved over 300 scientists from throughout the country. So the first one of these is related to rising temperature. I maybe need to read it from here because this is a weird angle. Rising temperatures are leading to increased demand for water and energy. Constraining development, stressing natural resources, and increasing competition for water amongst these various communities. A second key message was changes in the crop growth cycles due to warming winters and alterations in timing and magnitude of rainfall events. Once again, is going to, these have been observed and are going to require changes in new agricultural practices and livestock management practices. Landscape fragmentation related to the adaptation of species and their ability to move within the region is another one of the key messages. Another one was communities that are already the most vulnerable to weather and climate extremes are going to become more vulnerable in the future. And finally, the magnitude of expected changes will exceed those experienced in the last century. Existing adaptation planning methods and so on are inadequate. So one of the conclusions with regards to agriculture is the types of management practices or variations in management practices that we've used in the past to essentially adapt to our the weather variability that we experience in Nebraska all the time, that these are going to be inadequate by themselves, that it's going to require that we have more innovative management practices and new technologies, and also a better understanding of the climate and how we can incorporate these changes in the climate in management decisions. So, assessing the impacts of projected change. So here are some conclusions regarding the Nebraska climate projections. First of all, consequences depend on the sensitivity of key sectors. So obviously different sectors have different levels of sensitivity to these kinds of changes. The ability of these sectors to adapt as these occur. So how easy is it going to be for these different sectors to actually adapt to these changes? How proactive are these sectors going to be to these changes as they're occurring? The availability of groundwater is another key variability or variable here in terms of respond to increasing demand for water, and mitigation measures in terms of what we're going to do as a global society, as a national society, and so on to reduce greenhouse gas emissions. So another conclusion was slight changes in precipitation amounts projected, increasing temperatures and the number of high temperature stress days will be the critical factor affecting impact and the ability of various sectors to adapt to this changing climate. Some key takeaway messages. Dramatic changes in climate are being observed from global to local scales, and one of our big concerns is how rapidly these changes are occurring and will continue to occur in the future. Human activities are the drivers of this change. Projection of future changes represent the current state of the climate sciences. And so we obviously continue to increase our knowledge of the climate system and so forth, and that information is important. And the concern about surprises, things we don't understand yet that might cause us to be off in terms of these projections, either the projections being too low or possibly too high. Uncertainties associated with future changes are largely due to uncertainties in greenhouse gas emissions. And so again, the range of scenarios that are being looked at in order to get an idea about the range of changes, projected changes that are likely to occur. And obviously we must adapt to current and projected changes in climate and hopefully try to mitigate as much future warming as possible by reducing these greenhouse gases. Current and projected changes in temperature will have positive benefits for some, negative consequences for others. So usually when we talk about natural hazards occurring, drought for example, which I've worked in a lot, we talk about winners and losers. I think with climate change there are going to be winners and losers. Probably more losers than winners, but this is going to vary on a regional basis. If you look at the northern Great Plains that are projected to become warmer, more precipitation, there's some advantages that they can take into account in terms of their future planning regarding agriculture and other things. And a very important point is that early adapters will be better able to cope with the changes. So the sooner that various sectors can begin to incorporate these changes that we're seeing and that are projected into the future, the sooner they can incorporate those in their management, the better able they are going to be able to deal with those projected changes. So you don't want to wait, sooner rather than later. Changes in frequency and severity of extreme events will continue, resulting in escalating social, environmental, and economic costs. Embedded in all challenges are opportunities. So we really need to be looking at how we can improve the resilience of these sectors, these various sectors that I talked about, and other sectors that were not included in the study as well. And a final point is action now is more cost effective than reaction later. So understanding, developing awareness of these changes, understanding the science of climate change, and not denying that this science exists and what it's trying to tell us is not the path we need to go down. We really need to adopt action-oriented strategies to adapt to this changing climate while at the same time finding ways to reduce our carbon emissions. Thank you very much for your attention. We will now have a panel discussion which Ronnie is going to lead. Thank you very much.
Well, we now will ask the other three co-authors of the report to join Dr. Wilhite at the table. And as I had said earlier, if you have a question that you would like to address to them, please circulate it to the end of your aisle either way. So if you're on this side, go that way. If you're on this side, go this way.
So they've now turned
and those will be
so
collected.
They all should be live.
And we'll get started with some discussion. So as we're waiting on those first questions to come in, I would just point out to you, as Don said, the hard copy, printed copy of the report, we have 500 copies available here today that you can pick up on your way out of the venue. And it also will be available in PDF electronic form as he indicated online. So we hope if you want a copy today that you can get one and take it with you. I also would point out to you, we didn't say much at the beginning about this particular venue. It's a little bit different for a livestock guy like me to be standing on the floor of a former exhibition, livestock exhibition building, having an event like this. But I hope you will agree with me that the transformation of this facility into a new conference facility available for the public here at Innovation Campus has been a fabulous transformation. We have construction going on around us, as you see, in the first phase of the development of Innovation Campus, but we really appreciate the UNL Alumni Association who is managing this facility, this conference facility, and their hospitality in hosting us here today. So, questions. Do we have questions from the audience?
Ronnie, I might mention that to the students, they can pick up the cards along here, so we'll pass them down to the end of the aisles.
We'll just go straight with a good one right at the start.
Okay, Bob's going to answer that.
So these folks told me they were going to divvy over how they answer the questions. So whoever wants to take these on, please do so. Do faculty members at the University of Nebraska-Lincoln face funding pressures from outside funders to downplay the effects of human-influenced climate change? Told you we were starting with one.
We don't feel any pressure one way or the other, okay? The funding, I don't know where this confusion comes from, that we have to say certain things, our funding depends on it. That shows total lack of understanding of how the funding process works. No, our funding in no way, shape, or form depends on which side of the climate change picture we fall on.
That the prevailing opinion of the group? Okay.
Yes.
All right. Second question, what changes are needed in agricultural practices, and who will or which agency coordinate them?
I'll take a shot at that one, because I am in the Institute of Agriculture and Natural Resources. So while I'm not necessarily an agricultural scientist, but I think there are a lot of different organizations that need to become involved in this. Obviously, we have state agencies that need to become involved. Think about the Nebraska Department of Agriculture, but also the Department of Natural Resources, looking at a better understanding of water management issues in the state and so forth, and allocations and how climate change may affect the availability of water in the future. The university obviously has to play, I think, a tremendous role in this process, both in terms of educating our students, and it's not just the University of Nebraska, it's all educational institutions, and even K-12, educating our students about this issue, and through organizations like the Extension Service, for example. The Extension Service within INR has already launched a new initiative to develop a new action plan that's focusing on climate change resiliency. And so for those faculty that have extension appointments, I encourage them to become aware of this activity and to become involved in it and help in the development of this new activity. So there's a wide range of players, including players obviously in the private sector.
There are a couple of questions in the stack that relate to this one. I'll try to blend them together. What research and outreach is the university doing to help Nebraskans reduce greenhouse gas emissions in agriculture, electric utilities, and transportation? Related, what specifically needs to change in Nebraska to bring down greenhouse gas emissions? That kind of thread of question.
There are some people in the audience that might be better prepared to deal with that. I think through the Agricultural Research Division, there's a lot of research that's going on looking at reducing the carbon footprint of agriculture in general, but also for the other sectors. You'll see in the report there's a plot that shows for the principal sectors in Nebraska what the trend of greenhouse gas emissions has been over the last 20 or 30 years. And you'll see that all these sectors have had an increase. And so all of those sectors need to take part in this process of looking at how we reduce our carbon footprint.
I just want to remind that this is why we solicited all the expert commentaries for the report. We're basically experts on climate science. We can't be experts on every area that's impacted by that climate science. That's what the commentaries are for.
Right.
Also, Don pointed out the graph that shows the trends in CO2 emissions from various sectors. And we also have to consider the magnitude of each of those sectors. And the largest sectors are not necessarily agriculture or agricultural production. It's electricity generation and transportation are the two biggest sectors. And so there are people I know in the College of Engineering, for example, that are working on renewable energy and so forth.
Right.
So in terms of the university's contribution. It's on, but it keeps going on.
I think.
Sure.
They can adjust that up.
I'll just talk loud.
Or you can use Bob's mic.
I think, whoa, mine's really loud. I think to expand upon what Clint said in terms of, there are people in other colleges. We have a wide range of expertise at the university, and it's not just the hard sciences like climatology or engineering or even agricultural science. Climate change is multidisciplinary, and we're going to need all of the resources that we have at the university. We also need the social scientists and the psychologists to help bring people together, to help us have those conversations, to keep those conversations on a positive solution-oriented focus rather than a doom and gloom type of thing. So I guess I challenge all of you to think more broadly about finding the solutions and all of the talent that we have in this room and in the state and among our students.
I can't emphasize enough the importance of social scientists to be involved in this discussion for precisely the reason that Deborah was talking about. When we look at these future emission scenarios, we're looking at how we can change human behavior and to get people to value the environment for today and for the future. And physical scientists, as one group, you know, we don't necessarily understand human behavior, but that's the role of the social sciences. So they play a critically important role in this process of trying to move not just this country forward, but the world forward on this issue.
Okay, the next question. Does it make any difference to us in Nebraska in reducing greenhouse gas emissions or other ways to mitigate if India and China don't do the same?
Well, the reality is that China is really having some very serious discussions right now about reductions of carbon emissions. And we'll have to see how those play out. So they're beginning to step up to this process. I mean, I feel the United States as a technological leader that we've been for many, many years, that we need to be putting our best foot forward on this. And you have to think about the fact that we've created a lot of this problem. If you look at the energy dependence of this country and how much energy we use, we've helped create the problem that we see. And obviously this is going to be perpetuated by other countries like India and China.
Yeah, I thought that basically we in the United States, we used to think of ourselves as leaders for the world. Waiting to see how other countries act is not taking a leadership role.
Exactly, and while China has passed us in total emissions, we are still the leader in per capita emissions. And so we have to keep in mind that we have a long way to go and a big leadership role to fill. And there are, as Don pointed out in the talk, there are plenty of opportunities that are going to go missing if we don't take a leadership role. The development of new technologies to adopt means that we could license those technologies to other countries, to other adopters, and make money on the deal, not just spend money.
And produce some of those technologies in this state too.
So first of all, thank you for all these great questions, because there's, as you can see, quite a stack of them that have come in, and thankfully some of them are in buckets that are somewhat related. This next one has maybe a little philosophical approach to it, but I think it's a good question for you. Do you believe we, i.e. humanity, can fix this global problem, or is it too late and we must just prepare to adapt instead of prevent? Do we have the global political will and instruments in order to make change? Who wants that one?
That's a rhetorical question. We can't answer that for you. In fact, the people in this room can't answer that because the people of the globe as a whole have to answer that. Do we have the will or do we not have the will? I mean, we're all in this together. We all live on this planet together.
And this is the place where the United States could provide strong leadership rather than being a reluctant, if at all, follower. Rather than waiting for somebody else, if we take a leadership role, I think we could provide some political backbone to the whole world.
I think the same goes for the state too. I mean, the state can be a leader within the United States.
Okay, this is a technical question, so Don, I'll throw it to you. What is meant by plant hardiness?
Plant hardiness. Well, we're talking about the ability of plants to essentially sustain cold temperatures and so forth and survive that. So when we talk about plant hardiness zones, many of you have gardens, and when you plant seeds, you look at the back of the seed packet and you see whether or not the seed you're going to plant is adapted to live in this climate. And obviously you're not going to be planting palm trees in your backyard because they're not hardy in our particular climate. So
Yet.
Yet. Yeah. Good sidebar comment. Okay.
This next question, there are several in here that relate to this. Insurance was added as an impacted sector. And I know, Don, you had mentioned in some earlier conversations in the last few days the importance of the insurance industry in Nebraska certainly is part of the reason for that. Please touch on the findings. For example, what did that commentary kind of say? So any summary comments there?
Well, yeah, the reason I chose to include that, even though it wasn't one of the sectors that was addressed in the National Climate Assessment Report, is because we have, Adam, are you in the audience, or did you ask that question? Adam Liska? There's Adam.
Yeah,
is that your question, Adam? Adam has been looking at the linkages between climate change and insurance. And many of you may know that the insurance industry is really probably the largest industry in the world. Incredible revenues associated with insurance. And so I showed a graph that looked at the frequency of natural disasters and the increasing frequency of natural disasters. This is of major concern to the insurance industry, and that particular graph was from Munich Reinsurance, which is the largest reinsurance firm. So they insure the insurance companies, and they are very concerned about the increasing number of extreme events and how this is impacting the insurance sector. And so it's important to Nebraska, which is why I included it in the report, because we have a lot of insurance companies that are based here. And so this is an important sector for Nebraska. And so I thought it's worthwhile, and this is a future study area, I think, for Adam and some of his students, and also for some of the climate science students or climate science faculty in the School of Natural Resources and Department of Earth and Atmospheric Sciences. Anybody else?
That it? This next one, and again, I'm trying to collate these that are alike, so there are several on this topic as well. Agriculture is both a huge source and sink for carbon. What needs to be done for Nebraska to capitalize on the sink side?
Well, I'll start on that if you guys want to add. I mean, I think there are a number of research programs that are going on that are looking at that issue of carbon sequestration and the role that agriculture can play. But one of the things I would say is that when a couple of decades ago, when a lot of discussion started about the role of agriculture in terms of greenhouse gas emissions and so on, a lot of those in the agricultural sector just walked away from the table instead of being at the table. And I think the agriculture sector now is going back to the table, which is a very positive thing because agriculture is an important contributor but also a mitigating industry to this particular issue. And so agriculture needs to be right in the middle of the discussion about this issue in the future. So anyone else?
I'm no expert, but I do talk to people who are in this area, and as I understand it, the two primary issues would be how much net carbon is actually stored in the soil as a result of agricultural activities, recognizing that vegetation cycles carbon dioxide on an annual basis, at least in the mid-latitudes. In summer, it's drawing CO2 down, but in winter, when the leaves die, it gives us the carbon dioxide back. Furthermore, it's also not clear what the long-term implications of storing additional carbon in the soil will be for the overall productivity of that soil. The jury's still out. I don't think the soil scientists really know that well.
And there are a whole thread of questions in here that relate to next steps, and particularly next steps associated with the use of the report. for policy, for use by government, so that things like, now that we have a better understanding of the science, how do we get the policymakers engaged, take action in the state, so forth. So comments on that thread of, hopeful use of the report.
Yeah, I mean, I think the report provides a foundation in terms of our understanding of climate science, climate change science, and its implications for Nebraska. I think the commentaries that were written by 12 different individuals, the majority of them were University of Nebraska faculty, but I also asked for commentaries from people outside of the university, so some state agency personnel are involved in those. We also have Milo Mumgard. Milo, do you happen to be here? Milo's in the back. He's a sustainability coordinator for Mayor Beitler. The city of Lincoln is doing some outstanding things already in terms of adapting to climate change and looking at mitigating the amount of carbon that we're releasing. So I think that the sector commentaries provide a starting point. The report itself obviously provides a starting point. But I think the next step is for various groups around the state, and I know there are a number of watch parties that are going on now, and there are going to be more. These various community groups, various groups that are really interested in this particular issue need to be communicating to their elected officials and asking them, what is your position on this? For example, has either gubernatorial candidate been asked that question? And if so, what was their response? I mean, I think we need to be probing our state legislatures, obviously our elected officials in Washington, D.C., and also our governor, our future governor, and so on this issue. So state agencies, I think, are going to play a huge role, but in order to influence, I think, the pattern of what state agencies will do with this report, I think you have to get to the governor.
Yeah, when Ronnie asked that question, or whoever asked the question, or Ronnie read it, I had a one-word answer, and then Deb actually said she had the same one-word answer. Vote. As Don said, talk to the people who want to be your elected officials and vote for the ones that are going to work to guide the state and the country in that direction.
And if you can't talk to them, look at their voting records online. They're all available.
And I would just add one comment to what the authors have said. The genesis of this report was actually because the legislature of the state of Nebraska in a previous session asked for a study of this area to be done, and some of you will remember the debate about that over recent months. And we felt it was very important to contribute to that area in what way we could, so we offered to do the report in the way that it's been done. So that's certainly the intent and hope of the use of the report, is that it will be informative for state and local policymakers as they think about adaptation in these areas. This next kind of focal area of questions, and there's about 8 or 9 of them that relate to it, relates to the water area. And you talked about, Don, in the summary, some implications around snowpack, some implications around groundwater, surface water, rain events, snow events, and so forth. And the questions all relate to concern about the Ogallala Aquifer. Things like, do we expect to see, or are you predicting to see, the changes in the aquifer in Nebraska similar to what we've seen perhaps further south already in those parts of the aquifer? Any further elaboration on that area? Groundwater resources in Nebraska.
It was very scary what happened to the Loup River during the summer of 2012. Historically, the rivers that come out of the sandhills maintain a pretty constant flow even during summer because they're so well buffered by the aquifer. Unfortunately, what happened to the Loup River in 2012, where the Loup began to look almost like the Platte River does typically in summer, that could be a harbinger of what will happen if the Ogallala Aquifer continues to be depleted.
And I might add, I mean, we have a tremendous vehicle in this state to manage that aquifer in the natural resource districts. And I think they've done an excellent job of doing that to date, but they need to be looking at this kind of information. If they're charged with the management of our groundwater resources for the future, and they're not taking into account the long-term sustainability of those aquifers under projected climate changes, then we've got a problem. And so the natural resources districts really need to take a leading role in this, because we don't want to go down the path of the states to our south, and there's really no reason for us to do this if we properly manage that resource and adapt to the changes as we see them.
Any other comments? A couple of questions in this line. The U.S. military was not consulted as a key sector expert in the list that the report provided. Please discuss what you know about military planning around climate change, if you have any comments there. And a related question, what about first responders and the public, for example, the National Guard, Red Cross, et cetera?
Well, let me address the perspective of the military. First, I will tell you that on October 30th, in the City Campus Union, there's going to be a lecture on climate change and national security by David Tidley, who is a retired Rear Admiral from the U.S. Navy, who's currently on the faculty at Penn State University. So again, he's going to talk about climate change and national security. I'll also tell you that recently, many of you are familiar with the General Accountability Office. The General Accountability Office is requested by members of Congress to do studies on a wide range of different topics. They were recently asked to do a study on the implications of climate change on the vulnerability of U.S. military bases around the world, of which there are many. They produced a report that indicated that there needs to be significant adaptation measures taken for many of these facilities, including things like the naval base in Norfolk, Virginia, from sea level rise. I'll also tell you that the U.S. Congress, in passing the military budget for the Defense Department, precluded the Defense Department for spending any of those funds on adapting to climate change. We have a huge disconnect on this issue, and the way to address that, again, is through voting and to finding out what your elected officials are doing or not doing to deal with this particular issue. Other comments?
I don't have anything direct.
Okay. Okay.
This next one this next one either came from a really good student or somebody's professor, one of the two. So the question is a technical one related to the curves that you show in the report for CO2 emission, greenhouse gas accumulation, those kind of curves.
Sounds like one of your questions.
Whether they are in fact linear or quadratic.
Oh. Hit it, Bob or Clint.
Quadratic is nonlinear.
Definitely nonlinear, yeah.
And the second question on that kind of vein is, by focusing on the late 1800s as a baseline, and I think there was a fair amount of inferences in the report about it since 1895, since the late 1800s. Are you cherry picking the data?
No, actually, that's just the beginning of the widespread observational record in the United States, and mostly worldwide as well. That we didn't have really good widespread observations prior to that time, so we're going back as far as we can in the instrumental record.
Cherry picking the data would involve taking a certain segment of that data, okay, say, oh, I'm only going to look at from 1998 through 2008. I'm going to cherry pick that data because those 10 years don't seem to show as much warming as the 10 years before, the 10 years after. That is cherry picking your data. We look at the entire length of the data that we have. If we had data that went back several hundred years, we would be using it. Unfortunately, we simply do not.
There are a number of questions that are along the theme of relating information on this topic. So who are the best messengers to relate information on this topic? There's some questions like that. And this one probably is more pointed. How do you address the gaps in science literacy and public understanding on issues as complex as this? For example, people who trust the science of climate change but don't trust the science of biotechnology and vice versa. Any comments there?
It's interesting, interesting
It's
question.
an interesting conundrum.
I wish I knew.
Well, it's certainly a dangerous trend in this country, maybe in other countries as well, of what's called denialism, which is essentially ignoring what the science tells us and then believing essentially hearsay or what's coming from non-credible sources. And so it's really important that we focus on the science and the science behind that science and so forth in the future.
Yeah, I winked at our provost who's sitting here when you said that, because Susan Fritz, the provost of the University of Nebraska System, we're glad Susan's with us today, gave me this book 4 years ago when I arrived on campus. The title of it is Denialism. And it goes through a series of case studies using a whole variety of things where there is a societal move to deny the science associated with those various things. And actually, the climate science was one of those examples, amongst biotech and a number of other things as well. This one's a fun question. I just want to know what you say. As a former skeptic myself, this is from the audience, have any of you been a late believer that humans are causing climate change? And if so, what made you change your mind? I think I know the answer to that, but I just thought I'd ask it anyway.
I was not.
I got interested in the study of climate in the first place because I became fascinated between the relationship of the advent of human agriculture in what we now think of as the Middle East and the impact that agricultural activity may have had on the intensification of desertification in that region. So I guess no.
My background is looking at the links between climate and changes in the land vegetation and how it affects populations and so forth. So. No.
I guess my question is, what do you consider a latecomer? Because if you look at me compared to these guys, I might be I might be a latecomer.
Good answer.
Did you write that
They
question?
are creative people.
I said that with I said that with love and respect.
We'll bring our questions to a close with this kind of thread of questions. So there's been a lot of interest in the report, and a number of the questions that came forward had to do with specifically agriculture's response to dealing with this issue. So how can agriculture respond? How can the agricultural community, including farmers and ranchers, respond to this? And there's two questions here. One is more general that says, how quickly and slowly will plants and animals, and by animals I would include wildlife as well as domestic animals, adapt to projected changes, percentage that might not be able to adapt? So that's a broader question. And then secondly, I think Dr. Wilhite, you mentioned UNL Extension. How fast can the farming sector expect to get advice from UNL Extension on ideas to farm smart or climate smart agriculture? Is now quite a topic amongst our efforts.
Well, on the second part of that question, I mean, Extension is launching this action program now and trying to bring together the faculty resources to address this. As I pointed out, because I've been involved with this process somewhat, it's important that we educate the educators, because the message, one of the things we've learned in looking at who do people out there believe, Extension educators rank very high on that list. So they are a good source of information. We need to make sure that they are giving out the correct information, the correct advice. And so all of that is part of what we need to work on within the Extension system. So I think that over the next couple of years, you're going to see that activity develop very rapidly. But once again, as been pointed out earlier, this is a very interdisciplinary issue. And so we need to involve many scientists within the University of Nebraska, many within INR, but beyond INR, in this process, how people learn, how we should be disseminating information, how we should package that information in order to change human behavior. So,
any other comments?
Well, in terms of adaptation of both plants and animals, probably not fast enough is the bottom line. And if there is even adaptation space available to certain ecosystems, for example, if you're a little rodent living in the high alpine environment and the climate warms up and you keep moving up the mountain, there's a top to that mountain and you can't go any higher. So your ecosystem space disappears, and so do you. And so that's a highly problematic thing. And of course, vegetation, while animals can move if they have a pathway to move through without going, getting run over on the interstate or whatever, they can move. But plants, it takes a long time for especially tree species and so forth, to move through space.
And I'll just leave one final, more broader thought on that. The geologic record, of course, tells us that the Earth's climate has undergone large climate changes in the past. We're talking generally millions or tens of millions of years ago. We also know that the geologic record tells us that the Earth has undergone mass extinctions, where many, if not most, of the plant and animal species existing at that time went extinct. Guess what? The two coincide. The big climate changes that the Earth has undergone in the past are when the big mass extinctions have taken place.
I might point you to the report. There are 3 commentaries focused on ecosystems. So I would point you to those 3 commentaries and the perspectives of 3 ecosystem scientists on this particular issue.
So we have 3 things to do with you before you leave, so we beg your patience for just a few minutes. The first is I would like to ask anyone in the audience who was a contributor to the report, commentary writer, co-author, specialist that was drawn upon from the university. So if you're in the audience and you were a contributor to the report, would you please stand? I know there's some here, as I saw them. Yeah. So. Secondly, we have a tradition in the Heuermann Lectures that we started 3 years ago now, that each lecturer receive a memento from the university to remember their Heuermann Lecture. And it's a commissioned medal that we provide that it has a very nice picture on it related to the tree of life associated with what we do in agriculture and natural resources. So we have medals for all 4 of our participants today to remember their time here as a Heuermann Lecture. So please join me in applauding Don and Clint and Bob and Deb. The lectures are all archived, and today's lecture will be available at 7 p.m. tonight. There were groups that requested it who are having watch sessions tonight with the lecture, so it will be up on the web at 7 p.m. This evening in its full length. I would draw your attention to the next lecture, which will be on November the 6th. It will also be in this venue. It is same time, 3:30 in the afternoon. It will be a panel discussion lecture that deals with communicating about agriculture in the 21st century. Deals with some of the issues we talked about today, about science and application of science and controversies around some of those applications of science related to agriculture. It will be moderated and led by Orion Samuelson. Mr. Samuelson is a longtime legend radio broadcaster from Chicago, WGN. He's thought of as the voice of agriculture in the Midwestern United States. He will moderate the panel. It will include Barb Glenn, who previously was with CropLife America, before that was with the Bio organization in Washington, just recently became the CEO for the National Association of State Directors of Agriculture in the U.S. It also will include Marcy Tessman. Marcy is the president of Charleston Orwig, which is one of the largest agricultural media organizations in the world, located in Milwaukee, Wisconsin. Kevin Murphy from a group called Food Chain Communications, Inc., that deals with the livestock sector in particular and a lot of issues around the livestock sector. And I couldn't resist this one, so I'm going to sit on the panel as well and prod them along the way. So put that on your calendar, November the 6th, in this venue at 3:30 in the afternoon. In January, we will have Allison Van Eeneman from the University of California, Davis, coming to give the lecture on animal biotechnology, all of the issues around animal biotechnology. Allison will receive the Council of Ag Science and Technology's National Communications Award in about 2 weeks in association with the World Food Prize in Des Moines. And I can assure you she is a compelling and exciting speaker that we're looking forward to having here in early January. So welcome you to those lectures in the future. Please join me again in thanking the panel. Remember, the copies are available on your way out.